Oh, yeah, no, it does.
All right, so here we are. We're live. It says right there, live. So, yes, our schedule for today is that we'll talk about ANOVA for a while, and then we'll start doing the review. We'll talk about review situation today, then we'll review more on Monday, and then the test number 4 is a week from today. Specifically with regard to the resources that we have, if we go to the notes section, go all the way down, there are the test for review topics. Okay, so we'll go through this in more detail, but just so you know, it's out there on Blackboard. We have a list of topics for test number 4, and then we have review problems for test number 4. So we'll go through the topics today, and we might do a couple of examples to see how it works. And then we'll go through these review problems on Monday. Certainly it's not an assignment, but it's a positive thing for you to work on so that when you come on Monday, you'll know what's going on. All right? So any questions about the schedule at all? Good. So the first thing we want to do then is to go through ANOVA. And we're looking here at this assignment, which is out there on Blackboard. Now, what I want from you is either this printed out with your answers written on it, or a separate sheet of paper with your answers written on it, okay? But I want you to have written down the things that you come up with for this particular situation. Now, of course, we're talking about it during class. So what that would mean is if you're paying attention and you write things down, you could get things right. That's okay. But the bigger issue is, do you know how to do it? Not can you write down the answers? So it's unfortunate sometimes people look at this and they say, oh, this is a great homework assignment because I can just write down whatever the teacher says and get credit for it. That's the bad thing. Because if you just write down what the teacher says, you should not get credit for it. Because that's copying. But if you think about it carefully while you're writing it down, then that's good. And then, yeah, you're thinking about it, you're understanding it. So if you don't understand it, you need to. Because it's going to happen on the test. And you need to be able to understand what's going on so you can make it happen on the test. So this is where I leave it up to you to actually do the thing that's necessary, which is to ask any questions you might have about what's going on. So here we are, and it's talking about a data set which is in our textbook, which is on page 660. And if you were able to go there, you would see that there are like 12 different things that are measured for each individual. So they have their age, their smoking status, their weight, their cholesterol, blood pressure, IQ levels, sodium, gender, and marital status. All those things are out there. Okay? So then, the question we're working with here is average IQ levels for 3 different categories. And as you can see, this is ANOVA. So when we say we're doing ANOVA, then we have to ask the question, what kind of data is ANOVA talking about? Can somebody tell me what's the kind of data that ANOVA is talking about? Well, that's what it means, but that's not the kind of data that it's talking about. What kind of data are we using with ANOVA? We're not doing p-values. I'm sorry, Jackie? We're comparing what? Averages. We're comparing averages. Okay. And in order to compare averages, we need to have our data sets in different categories. So in a sense, we're asking people two questions here. We're asking them, what's your IQ, which is a number, and then we're asking them, what is your marital status, which is kind of a yes-no question with 3 different levels. So we have numbers, and we're finding averages for IQ. And then we're putting people into categories, so we have a list of numbers, and then another list of numbers, and then another list of numbers. The categories are all separated out. And we're asking the question, what can we find out about these averages? Okay? So, when I say draw the appropriate conclusion, the first thing that would mean here is this is a hypothesis test. You need to do a hypothesis test using ANOVA for this right here. Okay. Lisa Peterson, can you tell me what hypothesis would be the null hypothesis for this situation?
The different categories are the same.
What is the same?
The average.
The average would be the same between the categories. Okay? And when we're saying average, what's another word we use for that? Mean. And specifically in this situation, we're talking, are we talking sample mean or population mean? Wrong. Okay? We do not want to know information about the samples because we already know it. If I look at a set of sample means, I know everything about a sample mean. That's not what ANOVA is trying to figure out. When we say we're comparing averages in different categories, and I had this conversation earlier today, when we say that we're comparing averages for different categories, what we really are talking about here is the population mean. Hopefully, and I realize, you know, there's a lot going on here, but the fact is, we never just want sample information. We want, based on the sample, to understand the population. So I have a list of 100 people in this data set. I really don't care about these 100 people. I care about who they represent. So what I'm hoping is that based on what I've got here, this is a random sample. And so it's going to tell me about all the married people, all the single people, all the divorced people, and the relationship of their IQ levels. So I'm using a sample to understand the population. That's the process of statistics. So when I'm comparing these averages, I want to compare the population mean for these different things. All right, Lisa, does that make sense? Mm-hmm. Good. So, Jackie Miller, can you tell me what are the symbols that I use for the null hypothesis? Okay, so what is the null? Yes. So what does that look like then for the null hypothesis for this situation?
mu1 is equal to mu2 is equal to mu3.
Okay. And what do those numbers 1, 2, and 3, what would they represent? Of what for this situation?
Of the categories of like the divorced, single, or married.
That's correct. So we have different categories. So we can pick 1, 2, or 3. It doesn't matter. But that's what those are representing, the averages of the 3 different categories. And right now, the null hypothesis is that they would all be equal to each other. So Emily S., can you tell me what the alternative would be? At least one is different. Okay. At least one mu. All right, so far so good. Now, I want to do a hypothesis test on this. So I need to know how that works for ANOVA. Yeah, I do. I sure do. Danielle in the front here, can you tell me how this works for ANOVA? How do I do hypothesis testing?
I'll tell you what I think.
Okay, well, let's go ahead with what you think. Let's start with that.
Is this where we had to look at the chi-square distribution?
No,
and see if
not
it's
at all.
between?
This is not chi-squared. Nope.
Well, dang.
Sorry.
Then I
Well,
had
you were
no
thinking,
idea.
but you were thinking wrong, unfortunately. All right. Allie, what can you tell me? How to do hypothesis testing for ANOVA? Can you tell me how to do that? Wow. 0 for 2. All right. Emily Grenier, can you tell me how to do hypothesis testing for ANOVA?
You look at the p-value?
Yes, we do. Okay. And what do we say?
For this one or like in general?
In general.
If the p-value is less than alpha,
You don't reject or you do reject? Oh yeah, if the p-value is less than alpha, reject the null hypothesis.
Okay. This is how we do hypothesis testing for ANOVA. Hey, Allie, does that look familiar?
I had that written down.
Okay, all right.
Yeah.
So good. So yeah, I'll make that connection, right? Danielle, right?
Yeah.
Yeah. Okay. Relatively simple, one-step process of hypothesis testing for ANOVA. Okay. So, Allie, can you tell me what happens here?
P-value is at less than alpha.
All right. What's the p-value according to this?
0.3803.
Is that less than alpha?
No.
No. So what do we say?
No decision.
Okay. Kind of. We say do not reject the null hypothesis. No decision. Okay. Now that's one thing that we can say, all right? What we were trying to prove is something about the population mean of IQ levels for different marital status. So what we would say, when I say do not reject null hypothesis, no decision, what's the other thing that I could say here? Allie, can you tell me what's the other thing?
That one of them.
Nope, sorry, that's not correct. Danielle, can you tell me what else I say besides no decision when I do not reject null hypothesis?
At least.
No, that's not what I say. All right. Nikki, can you tell me what else I say?
There's not enough evidence to prove the alternative.
Oh.
There is not enough evidence to prove the alternative.
All the rooms
No,
are equal to.
no,
Really? That's not.
no. There is not enough evidence to prove the alternative. Okay. So there's not enough evidence to prove what?
One of them is different.
That one what is different? What does mu represent? Okay, what are we measuring? Of what?
The marital status.
No.
IQ.
IQ level.
Oh.
Okay? So what I want for an answer is to take what we just wrote up here and to put it in words that relate to the actual stuff that's being measured here. Okay?
How would you word that then?
I'm getting there. I'm not there yet. I'm actually going to ask someone to help me to do this. I'm not just going to tell you how to do it. I'm going to ask you how to do it. Okay? There is not enough evidence to prove what? Emily, yes? Prove that
Average IQ or whatever.
average IQ.
Same for those three categories.
Okay, what's the alternative hypothesis?
That one is different.
Okay, so there's not enough evidence to prove that average IQ is different.
Yeah. Category
Is different for what?
for single to married people.
For different marital status.
Go.
Not quite.
Dang.
Oh my gosh, seriously?
How long is it gonna be?
I don't want this word average. What do I want? What kind of?
Population mean.
Population mean, that's
That's
right.
the population mean, thank you. You have to have a thought there, then.
There's not enough evidence to prove that the population mean IQ is different marital status. That's what we have gotten to.
So that's what we should write down?
That is what you should write
Not
down.
just the do not.
Not just the that, correct. Okay. Technically, the way that I think about this is the do not reject is the decision, but it's not the conclusion. Okay? You decide, do I say reject or do not reject? But my conclusion is based on that decision. I decide what to do, but then I have to decide what it means. Draw my conclusion, okay? This is the conclusion. All right? Now, if we say there's not evidence to prove a difference, are we able to say that they are the same? No. So we cannot say that the three are the same. We don't know. Pretty much it's kind of obvious that we're going to get different numbers when we go out and do this thing. But the differences that we find are not significant enough. Okay? There's probably a difference when we did our samples, but we are not able to prove differences between the populations. Okay? And certainly marital status can be a fraught topic, as you might consider. But if you say single people are not necessarily smarter or less smart than anybody else, okay? And the same is true for the other. We don't know if there is a significant difference. There might be, but we just don't have evidence to prove it right now. Maybe if we had 1,000 people instead of just 90, maybe we would find some kind of a pattern. But for what we have currently with our data set, we are not able to prove a difference in IQ levels between these three things. Okay. This is something that's going to happen on test number 4, is that I'm going to require you to express your answer based on the statement of the problem that you're given. So that if you just say reject the null hypothesis, that's not going to be full credit. Okay? You need to be able to say what that means and to connect it back to the actual statement of the problem. So that's why we just did this thing here, so that you would see what that looks like. But again, when we get to the end, the basic idea is no decision. We cannot make a decision about there being a difference. Can't see that. It's not enough. Okay. Any further questions about this one? All right, so let's try the next one. We are going to page 630 and number 18. And I suppose it makes sense for us to find out what that is. Here. Ebook. Page 608. Number 8. What? 628. Nope, 630. What? Okay. I get it. I get it. Too much coffee, right? There we go. All right. Can I go big? Yes. No. Now, you saw that, right? I clicked where it said text size. Did it make any difference? None. Okay. Everything bigger. Okay. All right. By the way, I'm not sure if you knew this, but carbohydrates are a problem. Just throwing that out. So here we are with these fast food sandwiches. Just to make another point here, it's been found that eating French fries is highly associated with all kinds of health problems. But you know why that is? Most people don't eat French fries at home. So you're probably eating out a lot. If you are, then that's probably a problem. So if you order the salad, maybe that's better for you. Just saying.
Actually, I've heard that most salads at fast food places are worse because of the dressing.
Worse, yeah, so just don't eat the dressing.
Worse than or just like don't go out to eat, but.
Oh, well, you can go out to eat as long as you ask for the. Oh, just eat the fries, not the salad. All right, sure, fine. Yeah, but everything in moderation, right? Right? Everything in moderation? Most things in moderation. How about that? Okay, so here we have our question regarding the thing. We are comparing the population mean for different categories. We have the same null and alternative hypotheses here, but the actual thing that we're measuring is substantially different than what we had before. Okay? So here's the situation. And then we're going to go to the actual assignment to look at what it says. It looks like this. Okay. So, Donna, can you tell me what's going to happen here? Based on what's in the table. Yes.
We're going to reject the hypothesis.
We are, and why are we going to reject it?
Because there isn't enough
No.
evidence. No?
Sorry. Why are we not going to reject it?
Why?
Not the results
Yeah.
thereof. Why are we going to reject it? Why are we going to reject the null hypothesis? How did you decide to reject the null hypothesis?
I looked at the alpha numbers and the p-value.
Okay, and what did you find?
I found that the p-value is less than alpha.
That's right. So p-value is less than alpha, so we are going to reject the null hypothesis. Okay. All right. So Abby, what does that mean?
So that means that there is enough evidence to prove the alternative.
That's correct. There is evidence to prove the alternative. Okay, so Abby, what does that mean?
What's the gamma?
Okay, so if we go back to the data, it's like this.
Is it the calories?
It is calories. So that's the first thing we're talking about, are calories. Okay. So if we say at least one population mean of calories for what kind of burger does it say here?
Calories per burger in the left one.
Okay, but what does it say about these burgers? They're frequently ordered. Okay, population mean of calories is frequently ordered burgers.
But isn't it frequently ordered sandwiches?
Yes, this is sandwiches, but this says specialized in burgers,
Well, that's
and
what the
this says
restaurant-
calories per burger.
But it says frequently ordered sandwiches.
Because they are,
Huh?
How about we just-
okay, when it says per burger,
But it says the list is talking about frequently ordered sandwiches.
but this says per burger.
That's
So-
what it says sandwiches.
Right, and this says they're specializing in burger.
Or survey to find out the number of calories in their frequently ordered sandwiches. So
Right.
it's about their sandwiches, not just their burgers, because they could have
But-
a chicken sandwich.
That's true, except that this says per burger.
Oh my gosh.
So I have to say that the person who wrote the question was confused.
They're stupid.
They're not stupid, they're confused. There we go, yeah. And everybody says, like me. All right, you're not stupid, you're confused. Okay. At least, but we're not done, certainly, no, we're not done. At least one population mean of calories in frequently ordered burgers is different for what? For different what?
Restaurant? Franchise.
Restaurants.
Burgers? Did he say what it was? That it was right. Restaurant. Oh, I was right the first time.
Yes, you were. What are the categories? Three popular fast food restaurant franchises. Okay. Who do you think these people are? I mean, which companies do you think are represented? Probably. McDonald's certainly, Burger King certainly, Wendy's maybe.
What else would it be?
Or you were serving.
Culver's is only good.
Culver's is a Midwest thing. Nationwide,
Yeah.
yeah. Wendy's, oh, Hardee's was the other one I was thinking.
But Hardee's is also here. They have different.
Yeah, and this is a long time ago, and so Hardee's wasn't maybe as big as it was. So we're thinking those three, all right?
different questions.
This is the final conclusion for ANOVA. Okay? It tells us that at least one population mean is different. And we're talking calories of frequently ordered burgers. One of them, or maybe two of them, have, or three of them, have different population averages. However, I'm sorry to tell you, this is not really a legitimate survey. Okay? Because when you say frequently ordered burgers, you're not picking them at random. You're picking frequently ordered burgers. Okay, so it's most likely that you're not picking random selections here. But hey, we're just doing this. It's all just for fun here. So there we go. All right. This is the conclusion from ANOVA. So if I ask you to draw the appropriate conclusions using ANOVA, here you are done. Okay? That's not good enough for us. We also have this little chart right here. And what is the little chart giving us? Confidence intervals. Why would we use confidence intervals? To find out which one is different and the direction of the difference. With ANOVA, we don't know the specifics of the data set, and we don't know the direction of the difference. The confidence intervals are able to tell us that. Now, in just a minute, I'm going to tell you how this might not work, but for right now, it does work, so we're good. Okay? So, what are we able to say based on this information? Okay, so fast food restaurant number 3 is lower than the rest in what respect? The average of their burgers.
Average calories.
That's right. So that's what is less. Fast food franchise number 3 has a population mean, which is lower. Okay, not just an average, it's their population mean. So what this would maybe tell us is that on average, you average all the calories for their stuff, place number 3 is going to have a lower average than the other 2 places for their stuff. Okay. Would you consider that to be Wendy's, most likely? Probably. All right. So that's the conclusion that we're able to get. We would say that fast food number 3 has a lower population mean than.
So if we wrote that as a test result, this point, you're not pretty frequent, and they're frequently ordered burgers.
If you have it here, you won't get counted off. Okay. Once again, it's relatively important that you understand this is not just talking about the samples. We're saying that this is true for this place, for their stuff. It has an average which is lower. And it's also kind of important that you would say it's not true for each individual item. You could certainly maybe order something at Wendy's that would have more calories than something at McDonald's. We don't know that. These are just averages. Okay, then we keep going. Problem number 20, which is on page 630, which we already kind of did, but not really. Okay. Here it is. Average debt of students at graduation for certain states. Now, okay. So they just picked a state and found different data values and said, hey, what happens here? Okay. We are doing the same thing. We are comparing the averages or the population mean in different categories. How is my null hypothesis different for this problem? There are 4 of them. All right. Taylor, can you tell me what I need to do here?
Need to come up with a decision, so you need to check the p-value with the alpha to see if it's greater or less than.
Okay, and what do you see from here?
It is less than.
Okay, so what do we decide?
If it's less than, the null hypothesis.
Okay, so we do reject the null hypothesis. Humphrey, can you tell me what happens when I reject the null hypothesis? Sorry, it's the other way around. There is enough evidence, okay? Natasha, can you tell me there is enough evidence for what?
That at least one population mean of death at graduation is different.
That's correct. There is enough evidence that the population mean of student debt is different for different states. And we should probably say these 4. Because we're not talking all the states, we're just talking about states. So based on this information, we know that there is some difference somewhere between averages. Okay? But we don't know which one, and we don't know the direction. Okay? So, Alyssa Peterson, can you tell me what I do next?
Pennsylvania has a higher debt at graduation than the other 3 colleges.
Almost. Pennsylvania has higher debt than other what? What are we comparing?
Average
For what categories?
for both our states.
States. Okay. Pennsylvania has a higher debt than other states. Not higher than other colleges. That's not what that is. But we're not quite done here. Higher what? No. What word do we use to describe what we're measuring? Population mean. Okay.
Would you put other 3 states? Because we put Florida in the other one? Is it-
Then other,
You said if we wrote the first part with all those risky rates, just Pennsylvania, higher population mean other three.
yeah, as long as you make sure you have it someplace, then I'll know what you're talking about. Okay. The textbook author is from Pennsylvania, so that's probably why they did this. Hey, look, Pennsylvania. Not in a good way, but hey, c'est la vie. All right, so this is ANOVA. This is how it works. This is what you'll see. You'll be given basically what you see here, and I will ask the questions. What conclusion can you draw from this? Based on the statement of the problem, here's the ANOVA table. What conclusion can you draw? And then here is confidence interval information. What can you find out from that? Okay. Confidence interval information will probably not be in graph form. It'll probably just be the numbers. So we should probably do an example of that. So let's go get that if we can. Can we? I don't know. Sure, there we go. Okay, so. Studious. Okay. ANOVA. Yeah. So that's not really what I want. I mean, if I hit compute here, it'll give me this. Oh, just as a reminder. What would happen if I gave you this information right here?
Look at P-value.
I would not.
Look at the mean.
I don't have this, just have this. No. What happens when I do this? I just have this and I don't have this down here. I would say I cannot draw a conclusion because this is just sample data. Okay. Even though this mean is higher than the other three, I do not know just by looking at this whether it's a significant difference or not. It's important for you to know that because I'm going to ask you that question on the test. Okay, I'm going to give you a set of data, a situation like this, but what you will need to understand is that you cannot draw a conclusion simply from the sample data. You have to have this down here or to draw a conclusion. Sample data by itself does not tell you there's a population difference. Even though it's clear that this mean is higher than the other three, we don't know if that's a significant difference until we go through and do the rest. Okay? So sample data by itself will not tell you if there is a significant difference. Now, let's make this happen. Okay. I'll admit to you that there's a lot of numbers up here. Okay? What I want you to be able to do is to figure out how you will know when there is a significant difference based on what is here. Oh, I need to change this though. We're going to make it a 90%. 90. Interesting. Okay, here we are. I'm going to look at these numbers and I'm going to try to make a specific decision about a difference between confidence intervals. It's not necessarily easy, so hopefully you can figure this out. Here are my lower and upper limits. I want to make sure that there is a difference between these confidence intervals. Okay? And the way I make that decision, I say any upper limit which is less than any lower limit. Okay, so I'm looking at upper limits to see if they're lower than the lower limits. Okay. Emily Grenier, can you tell me any results here?
New York one, less than the Pennsylvania.
Okay, so I can say that the mu of New York is less than the mu of Pennsylvania. What else?
How do you know that?
Okay, so the upper limit here is less than the lower limit here. So this group is lower than this group. Allie, anything else?
California, lower.
California is also lower than Pennsylvania. So that means the population mean of California is also lower than New York. There aren't any others that we can say based on this. Okay? Because when we look at Virginia, it's 16.9 and this is 16.0. So Virginia does overlap Pennsylvania. So Virginia technically could be higher and Pennsylvania lower, or the other way around.
So what are you saying that's telling us?
This is telling us the specific relationships that ANOVA does not tell us. ANOVA just says there is some difference. But now what we're able to say is New York is definitely less than Pennsylvania. California is definitely less than Pennsylvania. Those are the only ones we can do. Okay.
So if you gave us that on the test, would we be able to retract it?
I was asking, it's giving us enough information to make any decisions, or just giving us more information for our decision?
Kind of both what you're both saying. Okay. First of all, when you say, can we reject the null hypothesis? Can we say that at least one of them is different? That's really an ANOVA question. And ANOVA, we said, yes, there is a difference somewhere. But with the confidence intervals, we're able to say which difference is real. Okay, this difference, also this difference, are actual differences.
Are you gonna give us any chart like this on the test?
Yes, I am.
So do you want us just to like write it like that, or do you want us,
That would be great.
that's all we have to do?
Oh, yeah.
Okay.
Okay. Standard. Okay, so what we have in making these decisions is to be able to be more specific, and the confidence intervals are able to tell us that. There is a problem. We're going to talk about the problem right before we go to break. Aha. Let's say that I have a chain which is made of links here. And I have 4 different links. I want the chain to hold. In order for the chain to hold, I have to have all of them work. Okay? But what I just did here, I said these are 90% confidence intervals. So we are only 90% sure that these are the correct things. So if I want all of these to work, I'm going to take 0.90 to the 4th power. What happens when I take 0.90 to the 4th power? Okay, so it's about 66%. So when I start talking about using these things and I say, okay, can I find a difference using confidence intervals? In order for my confidence intervals to work, all of them have to be correct. Otherwise, there's something that could be wrong with this. So unfortunately, that means I only have 66% confidence instead of like 90 or 95% confidence. Now there are ways to get around that. There's extra calculations that could be done so that we can make this work. We're not going to worry about those, but just so that you know, even though confidence intervals are good, once we start doing these multiple confidence intervals, and once we start saying, well, I have to make sure that all of these confidence intervals have good information, we can run into trouble. So it's a more advanced process, something called the Bonferroni procedure, believe it or not. But if you use the Bonferroni procedure, then you are able to make actual distinctions. And if you have a computer software like this, and you can say, wherever it is, oops, wrong place. If you can say, let's do ANOVA with compute Tukey HSD, and then you hit compute, then you get Tukey HSD. And what you find is Pennsylvania is different from Virginia and New York and California. So if we had done Tukey, then that would have said that all 3 of them are separate. So just so that you're aware that there are more advanced things to do once you start working with confidence. All right, so we're going to take our break now. Come back at 4:04. And we're going to start reviewing for the test. All right, so I'll see you in 10 minutes.